Can you tell me what dates you worked in RCA?
Yes, I worked from September 1953 until January of 1989.
About a long time.
About 36 years.
What was your job title?
Computer systems engineering.
Oh, computers. How did you get your job at RCA?
Well, after I graduated from college, I had two other jobs. One in Philadelphia, and I worked there for just a few months because I found out that they were what they call stacking engineers. I had an engineering degree. They were stacking engineers for a future job, and I wasn't doing anything, so I left there, and then I went to Allentown, worked for a small manufacturing engineering company, and it was a great future. But when I met my wife, she didn't want to live up there, so we moved back to Philadelphia, and went to work for RCA, and then I stayed there for my whole engineering career.
Can you describe what did you do at RCA?
Primarily, I worked on mostly hardware systems in the beginning, designing hardware receivers, things for the military. Like, for example, we constructed a small receiver that operated with an antenna on the top of a submarine. And the idea of that was to any airmen who are downed in the middle of an ocean, they would have what they call a Betty, or they would have a way of transmitting a signal. The submarine would come to the surface and search, and you'd pick up the signal, and then it was a directional bearing system that would go right and rescue the airmen. This was a big deficiency in World War II because a lot of airmen were shot down or their planes crashed and they're floating in the ocean, and nobody would ever find them. You know, they might even have a raft. Like President Bush, he was shot down, and he crashed, but he had a small raft, and he sat on a raft, and he was found by a submarine, just lucky. But a lot of people weren't. So they decided that they wanted to have a system that they could locate airmen. But like then I went to, after that was finished, then I transferred up and started getting into space systems. You know, the tracking objects in space, and participating in not missile launches, but NASA launches, like satellites and those other sort of things.
What kind of wages did you receive?
Well, I primarily worked in software development. The systems, the radar systems and all that were, and on ships, but they weren't Navy ships. They were actually commercial ships, like Liberty ships, what they called, and Victory ships. Liberty and Victory ships were freight kind of ships that were used during World War II, but after the war was over, they had hundreds of these ships they didn't know what to do with. They scrapped a lot of them, but they saved some of them for electronics studies. So what we did, we would go out in the ocean. See, when they started launching satellites and spacecraft from Florida, they had a lot of tracking stations in the Caribbean, in the Gulf of Mexico, and all down through there. But they didn't have anything down toward the middle Atlantic, Africa, and around the Indian Ocean, and places like that. So what they would do is instrument ships so that they would be able to perform like a tracking station. One task that I worked on was very successful. Was in the early 1960s. I guess it was the spring of 1962. They were launching a Ranger, what they called a Ranger mission. And the Ranger mission was going to be launched from Florida, go around, partly around the Earth, and then be shot off toward the moon. And the idea was it would shoot off toward the moon, go around the moon, take pictures of the backside of the moon, because nobody ever saw the backside of the moon before, because there's only half the moon faces the Earth all the time. So, because it doesn't spin. The Earth spins, but the moon doesn't. So then it would go around, take pictures, and then it would come back and then relay the pictures back to land. And our job was on a ship to be what they call downrange in the middle of the Atlantic Ocean between Africa and South America. And when it was launched, it would come down and come up over the horizon, and we would pick it up and track it, and then send information back to Florida where they had launched it, where they had computers to compute exactly where it was going. So then they had information then that they could make corrections to the Ranger so that they would go exactly toward the moon and around it the way it should. And that was very, very successful. Another mission that was really interesting happened in the fall of 1962. That's when, I don't know whether you know about it, but the early manned launches were what they called the Mercury launches. They had 7 astronauts, and each one was assigned to a Mercury launch. And that started, I guess, around 1961. And they would launch them from Florida. They'd go around the Earth 3 times, and they would launch in the morning, and then it would go around the Earth 3 times, and they would come back to on the 3rd time they would come and re-enter on a parachute, and the capsule would land in there, and then the Navy would come up knowing where they were going to land and rescue them. So they did that for, I think, 5 missions, 5 different astronauts. And they always landed right near where they were shot off. But they wanted to, before it got dark, because they couldn't find them if it got dark, so they only had three orbits. Well, the next one, the 6th one, was with an astronaut by the name of Wally Schirra. They decided they wanted to go 6 orbits to prove that they could go around 6 times and could land somewhere else in the world. If they went around 6 times, it got dark in the Florida area, so they had to be recovered in the Pacific Ocean on the other side of the world. So our job was to go on a ship and go to a station near Midway Island in the Pacific and track the Mercury capsule as it went through we tracked it through the 5th orbit, so that we would have a very accurate idea of where he was coming on the 6th orbit. And the idea was at the 6th orbit, then they would re-enter. They would go to retro rockets and re-enter. And then they come down in the prescribed area. And our job was, if if something went wrong and he was going in the wrong direction, they would know where to go to pick him up. It could be 100 miles away sometimes. But fortunately, he came down very close. The capsule landed in the water not far from the fleet, the Navy fleet. So they picked him up and rescued him. So that was one very interesting shot. So that was called the Aegina Ranger type missions, and they were. I mean, that was no, that was the Mercury missions, and the one where they went to the moon. That was the Aegina Ranger missions. Mm-hmm. So they were kind of, in my mind, the highlight of my early career in engineering.
While working in the RCI, what were your relationships with coworkers?
Relation with what?
Coworkers.
Oh, coworkers? Oh, well, here, I have something here I can give you for later reference. That's all right. Here's an article written by, here's what the ship looks like. And this happened to be a mission where the astronaut came down in the Pacific Ocean near Midway Island. And here were the 8 engineers assigned for responsibility of the mission. And this is me here. That's me right there. So this describes the mission completely and what we did. And you can have that for reference if you want. Read it. And this is the ship that would track. See these antennas here? Mm-hmm. They were called FPS-16 radars. They were C-band radars, which were used, which got a good return from satellite systems, satellites, and the information from the radar would come down into the electronics area in the back, which I was responsible for, and that's where we had the computers to compute the
data.
Provide the data. So you can have that.
Thank you.
Also, on the mission for the moon, I wrote this article here, and this had to do with the computer that we used. I was responsible for building that computer, and also responsible for the software going into it to perform its mission. And this kind of gives you an example of the complexity of how to locate an object in space. If you look at this little point right in the middle, that's considered the Earth. Then you have this big ellipse out here, which represents the path of the satellite, and they call it the orbital plane. So the satellite is always going to go like this around the Earth. The Earth is, well, it's not really in the center since it's an ellipse. I don't know if you have mathematics in high school, but you have a focus, what they call the focus of the ellipse. And there's 2 focuses, one at each end, each in the middle, separate one another. If those focus points come together, finally, together, then it's one focal point, that defines a circle. But if they're separated, the focal points are separated, it's going to define an ellipse, either longer or shorter. So that's very important in the mathematics of determining orbits. All paths of a satellite form elliptical paths around the Earth. Now the Earth is spinning in the middle. The Earth is slowly turning. In what they call inertial space, this elliptical plane is fixed. Just the opposite. The object is going around there, but the Earth that's sitting at the focal point is slowly turning. makes one complete turn every 24 hours.